Hello. This amp is something I made back in the 80s, I believe. I made it for my sister. It was a kit amp, and I made it on a board, PC board that you bought as a kit, PC board and heatsink. It didn't have an input selector. I had to engineer that myself. Anyway, this amp worked for about 5 years for them. I'm guessing it's a long time ago, 5 to 7 years. And by that time they had small children. I had to repair it. The company that made the board was still in business, so I was able to get the parts, which was good because they were oddball parts. They were like European part numbers, English transistors and stuff. I redid everything, got it repaired, got this nice cabinet for my dad, built for it, and they used it for, probably another 20 years or more. So finally ended up in the closet again, and I noticed they were using some crummy Radio Shack stereo again. And they go, why are you using that? I gave you that stereo. So I got this back from them, and I gave them my Kenwood setup that I had at the time. Which is a nice little amp and preamp. Integrated amp and tuner. Separates. So, I also put all this hardware cloth on the back. I'm going to have to pull that off. That's going to be kind of a hassle taking this apart because this stuff's going to have to come off piece by piece. Not the heatsink, but this cross brace and these little staples and etc. Got to get loosened up before I can free it up. Then I just got to take the 4 feet off and the board will come out along with the front panel, I believe. At this point, I'm not looking at repairing it. I'm looking at trying to get a schematic for it so I can figure it out. It's always had kind of a temperamental protection circuit. It always took a long time for the protection circuit to turn on. And if there's any kind of offset at all, the protection circuit won't turn on. And I think that's what ended up happening to it. It just wouldn't turn on anymore. Which with this amp can just be a little offset issue or something like that. So I don't know how serious of an issue I've got. Well, both lights are on already. That's odd. Huh. Usually it takes a long time and then there's a click. All I hear is a faint meow from my cat outside wants to come in. So anyway, I'm going to take her apart and see what I can figure out. Maybe I'll try putting a signal through it first. I don't think I'm going to get anything without the protection circuit clicking. So maybe I'll just take it apart. Well, I had the relay turning on and off with the power switch. Some delay, but so I hooked everything up and now it won't come on. Interesting. I wonder if floating the speaker outputs will make it come on. That wouldn't make any sense actually. But I didn't have anything hooked up and it was going on and off okay, and now it won't go on. I think that's what was wrong with it though. The protection circuit's just getting real fluky. Controls are really bad. Yep. The protection circuit went out again. It's going on and off real slowly. There's no rhyme or reason to it. The controls are really noisy when they do work. So there's probably like leaky capacitors and DC offset or something going on driving the protection circuit to shut off. I don't know. I have to continue taking it apart. I had it on while I was taking it apart just to see if whatever would come on, but it's time to unplug the little monster and really get it apart. And here we are with the cover off. Foil lined cover. Foil lined front panel. Of course the little mesh in back. Pretty much a Faraday cage. So it was pretty well shielded the way I built it. Here's a look at the board. And my memory was right. The brand is Formula. Formula International, I think they went by. And it says TA-800. It's the model number, TA-800. Formula TA-800. I gotta look that up. See if I can get any information on this amplifier. I'd like to look at the protection circuit and norms. I guess I can look at DC offset and stuff like that. But I'd really like to get a schematic. Use 2 transformers to get enough current. It's a good little amp. Maybe 40 watts a channel, I'm guessing it with TA-800. And it was no 400 per channel. So that's the first look at this amp. What I built almost 30 years ago or more. So having a generic class AB amplifier in front of me and no schematic, I can still do some basic checks on it. Bias. It's a class AB2 amplifier, so I'm going to shoot for a maximum of about 50 milliamps for idle current. So I've set up to measure it here. I'm going across one of the emitter resistors, emitter or collector or whatever they are, but they're in the main line of the power. They're a quarter ohm, 0.25 ohm resistor. So for 50 milliamps, it's basically going to be a quarter of it. So I'm really looking for 12.5 millivolts. I'm getting 17.5 millivolts. I'm a little high actually. I'm going to taper that down a little while I'm in here, if I can. Wrong way. Maybe going off course here. These may be actually DC offsets, so I should really go back a step and look at DC offset before I even play with this. So let me set up for that. All I have to do different is get a ground going somewhere. This is my ground point. That's why I had those nuts on the front. This foil ought to ground me. To this green wire here, I got the green wire between the 2 emitter resistors. What I presume is going to be a common connection between these 2 resistors. Of course, I could verify that quite easily with the power off. But I get the power on right now, so I'm not going to bother verifying it. If I get weird readings, then I can try to figure that out later. Alright, so yeah, I got negative 39 DC. That's millivolts? That's volts. Ooh, we're blown. Or they're not common. I guess I got to do a little ohm meter work to make sure that these are common. But I'm getting negative 39. That's the rail. That means I'm blown here. Let's see if I get the same thing over here. Yeah, I do. That's not good. So this is probably about 60 watts a channel if there's got 40 volt rails. Looks like I got something blown in this channel. Huh. Let's see what the other channel looks like. Well, now I'm getting... Am I doing this right? Wow. Well, these are millivolts here. Or over here I'm seeing volts, right? Yes. Okay, so over here I'm seeing a more normal reading. I'm getting 47 millivolts. That's not too exciting. That's probably within the realm of normal. So this channel is probably working correctly, but let's see how that changes with the bias change here. And now I've got my wires back on the resistor here, and I've got 6.3. How warm are we? We're kind of warm because this thing's been just sitting here cooking. And I really went around 12, but being that it's not really heated up, I'm going to kind of compromise, shoot for maybe 8 or something. Okay, I'm going down this way. Oh, here we go. Yeah, this is down. Okay, so clockwise is down. We are in millivolts. I'm going to crank it till I get about 8 millivolts maybe for now. I want to keep it below 12.5. I got to recheck it when it's warmer, and I've jammed out on it for a while. Let's leave it at 9 for a minute. Yeah, so I'm going to set it like I said, around 8 for now until I have a chance to really warm it up. Let me go back to the other channel, because the other channel seems like it's blown. Getting a real heavy DC offset on it. Okay, back on the other channel now, this channel, I'm going to go to ohms, just plain old ohms. I want to make sure that these resistors aren't blown. So I think one of them might be. Nope. Looks a little high, but it doesn't look blown. Should be 0.25, 0.7, 0.8. Is that just me contacting here? Wow. Why are they so high if they're 0.25s? That's a mystery. Let me look at these outputs, make sure I don't see a short across either one of them. I don't know what the pinout is going to be in these. Probably the middle pin's probably collector. So maybe I'll just go to resistor volts mode. I'm in resistive mode, but ohms mode, but I'm going to volts for troubleshooting. That's just ohms. That's my diode symbol. It's kind of funky looking. Alright, so let's look at these outputs. That's my base emitter, I think. My base collector, and this is my base emitter. That looks good. That looks low. And that looks shorted. Collector emitter shorted, I think. How's this one doing? Well, we get some real low readings across these output transistors. I'm going to have to disconnect the speaker for starters on that channel, see if it measures any different. Alright, well, I'm going to turn it off from it and look at it more carefully offline here. I'll look at both channels, compare them to each other, but it looks like I got some blown transistors on this side, unfortunately. Maybe I'll turn this bias all the way down to, seems like clockwise was all the way off. Take another look at that offset. Scary enough for starts, just that offset. So let's go back. Ground. Oops. Well, now I don't have that big offset anymore. I've disconnected the speaker and I've turned the bias down. Let's take a little further look here. Tuck the speaker back in for yucks. There was a little something going on there. The relay isn't activated, so it shouldn't really matter. The relay is open anyway. Never heard the relay click and the light's not on. If I can trust all that. This channel's getting warm. Yeah, I'm getting a 5 volt. Is that millivolts? That's millivolts. That's not a problem at all. I'm getting a lot of heat here though. Wow, something's getting hot fast. Since I turned that control, maybe the controls are symmetrical and I gotta go the other way, I don't know. Getting hot fast though. Let me set up on this resistor. This channel looks like it's more or less okay, so I'm going to abandon this channel for now and go to this channel. But I don't know if I can trust these resistors. I'm trying to measure across these power resistors and they're all measuring a little high. Let's kind of throw everything off. If that's the story. And my alligator clips are crummy as usual. Okay, well, let's see where this goes with bias for starters. And I'll recheck the offset. Okay, so we're set up for bias. Across that resistor, looking at voltage. Hopefully in millivolts. And I am way, way high. Why? So that's why it's overheating. So yeah, the controls are opposite each other. Weird. Okay, well I'll set this one to about 8 as well. Actually, I'll set this one to about 9 or 10. So I set the bias to the other channel. Wow, it's gone way down now. I had it up to 8, but it's drifted down on its own. What is going on here? Are we still on? Yes. I guess just because it's cooling. There we go. Guess I got her pretty warm. So I can push it a little harder than that. It seems to be cooling. Seems stable at least. Probably knock it down just a hair. It's a little touchy there though. Okay, let's see where she goes from there. But I'm a little mystified by these resistors measuring so high. I'm going to have to go over them again carefully, scraping some bare metal on them and stuff. Good sharp probes and really double check them. If they're all high, I guess I got to replace them because that's going to really limit my power output if they're that high. It'll throw my bias way off. So if they're really that far off, they got to go. And the amp is not turned on even though I got the bias and control on both channels now. We'll look at that offset again. Very little offset on this channel now. That's good. Very good. Okay, so offset is way down on both channels. I don't know why the power's, I don't know why the... Oh, it is engaged now. The relay is engaged. That's why the offset's so low, is because the speaker loaded down the open terminals on them. So that's why the offset dived. And I can't remember which one was which. CD is what I want to go for. Okay, so theoretically I got audio input. I'm not getting any output though. He was getting output yesterday. There we go, it just clicked again. I don't know why I'm not getting any audio level though. Well, from the little bit I've seen, I'm kind of suspicious that the output transistor on the negative rail on this channel is a leaky, because when I had it initially with the relay open, and I saw that big offset, big negative offset, almost to the rail negative, and that went away when I turned up the bias, which kind of fits to get both transistors turning on, so the leakage is less important. I don't know, it could be other things. It could be a bad capacitor. Some of these capacitors look a little bit funny. This one size, well, maybe not. Or it could be a driver or anything else. But my initial knee-jerk reaction is I got a leaky output transistor. So getting this board off the board might be my next task, I guess. Try to remove the suspect output transistor. I got to make sure which one it is. If it's which one is the positive, which is the negative. I think that's the negative, but I got to check it. Well, let's test this transistor out. Went through all the trouble pulling it. My wild, crazy theory here. These probes aren't doing so well. That's why my resistors measured wrong. That's a shame. These are good probes. Yeah, that's a lot of 0.3 baseline now. Alright, so I'm hoping that the center is the collector like it is on most transistors. And it is. I'm still just plain ohms right now. And I'm taking it to be, I'm trying to think of a TO3 upside down, which is what this is going to emulate more. Well, you really can't. I don't know. This might be the base. This might be the emitter. Well, it looks like it's a good transistor. Or open. 3.5 megs one way. And no measurement the other way. This is probably my collector and my emitter, which means this is base, collector, emitter. And let me go to a different range here. Should be using the select hold button. Now I'm going through ranges, which I don't really want to do. What I really want is the diode mode. Okay. So holding on to my base. Get nothing, get nothing. Switch it around. I should get 0.6 on both of them. I'm going to waste my time. It's a good transistor. This is not my issue. It's such a good theory, though. Oh, wait a minute. Am I open here? Am I wrong about my collector emitter thing here? Yeah, I was wrong. This is the base on the right. Okay, so it is a good transistor. So I have to look onwards for my problems. So I think at this point I'm going to probably box this up and go after it again when I get some kind of schematic. And with my active tester, I'm getting pretty good gain out of this transistor. This is approximate beta on the scale here. Like 70, that's really high for an output transistor.